Although the Perseverance rover has only been on the planet for 10 months, it has already made an unexpected finding. These discoveries made by the rover are game-changing and go to offer more proof that Martian life may indeed exist on Mars. Welcome to Tech Bang, and in today's video, we shall take a look at the latest images of proof of Martian life on Mars.
Has there ever been life on Mars? Can there be life somewhere in the solar system?
This is a place where we are very certain there's a lot of water.
Curiosity is the longest and heaviest rover on Mars, measuring around 3 meters long and weighing 900 kilograms. Spirit and Opportunity, the Mars exploration rovers, are 1.6 meters long and weigh 174 kilograms. Curiosity's landing, unlike previous rovers, was not cushioned by airbags. Instead, due to its large size, it was brought to the surface by 3 tethers from the spacecraft's body, known as the Sky Crane. The rover's latest discovery shows that the bedrock it has been driving over since landing was previously produced by volcanic lava flows, which mission scientists described as totally unexpected. They previously assumed the stratified rocks photographed by Perseverance were sedimentary. Perseverance's rocks have also indicated that they had interacted with water several times and that some of them contain organic molecules. These findings could aid scientists in constructing a precise time frame for events that occurred in the Jezero crater, the site of an old lake, and have broader implications for our understanding of Mars. The discovery was made at the American Geophysical Union's fall meeting in New Orleans. Scientists have debated for years whether the rock in this crater is a sedimentary rock made up of layers of material deposited by an old river, or igneous rock formed when lava flows cool. In April, Perseverance captured this image of the Jezero crater. Kodiak is a flat-topped hill with ancient stratified rocks. In a statement, Ken Farley, Perseverance project scientist at the California Institute of Technology in Pasadena, said, "I was beginning to despair. We would never find the answer." When Perseverance began scraping away at the surfaces of rocks with a drill on the end of its robotic arm, everything changed. The smoking gun was the crystals within the rock, Farley explained. Perseverance has a number of advanced devices that can photograph and analyze scraped rocks, revealing their chemistry and mineral concentration. Pixel, or the Planetary Instrument for X-ray Lithochemistry, is one of these instruments. Perseverance used its instruments to analyze a rock that the team dubbed Rock in November. During the research, large olivine crystals surrounded by pyroxene crystals were discovered, indicating that the rock came from volcanic lava flows. The team now wants to determine if the olivine-bearing rocks came from a subsurface chamber of lava that was subsequently revealed due to erosion, or if they came from a cooling lake of lava. This was entirely unexpected, Farley said, and we're still trying to figure out what it means. However, I believe that this is not the original crater floor. We predict the original crater floor to be substantially deeper than where we are currently, based on the diameter of this crater. He believes lava may have flowed down into the crater, but the original crater floor is below the rock they are currently driving over. Over time, these rocks reacted with water, forming new minerals. The minerals in the samples can give information about the climate and environment on Mars billions of years ago, as well as the composition of the water. Perseverance has acquired 4 rock samples thus far, with the possibility of collecting up to 37 more. Future missions will return these samples to Earth, allowing them to be analyzed in great detail and in a number of ways. The Jezero crater and its river delta samples could show whether or not life ever existed on Mars. Volcanic rocks can be dated with extreme precision once returned to Earth. Thus, these new samples could aid the scientists in establishing more precise dates for features and events on Mars. That will tell us whether the water that was there in the past was potentially habitable, said Kelsey Moore, a geobiologist and postdoctoral scholar research associate in planetary science at the California Institute of Technology. The rover's Sherlock sensor, which stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, also found organic compounds in the rock it tested. The presence of organic molecules does not always imply prior life signs or biosignatures. Organics can be made biologically or abiotically, which means without the need of live beings. The Curiosity rover, which landed on Mars in 2012, identified organics in Gale Crater, where it landed. In a statement, Luther Beagle, Sherlock lead investigator at NASA's Jet Propulsion Laboratory in Pasadena, noted that now that Perseverance has discovered them as well, this helps us understand the environment in which the organics evolved. While further research is needed to figure out how these organic compounds came to be, their presence gives the scientists optimism. That's because it indicates that if life had existed on Mars, indications of past or contemporary life could be preserved as well. These samples will be a source of scientific inquiry and discovery for many years. When they are returned to Earth, Beagle added. Perseverance has also been employing its ground-penetrating radar equipment, which is the first of its kind to be tested on Mars, to peep into the subsurface and assess the structure of a rock under our wheels, said Brianne Horgan, Associate Professor of Planetary Science at Purdue University and a scientist on the Rover expedition. As the rover drove across a ridgeline, the experiment was carried out. Multiple rock formations with a downward tilt were discovered in the radar data, which continue below the surface from the ridgeline itself. Instruments like RIMFAX can aid scientists in creating a more accurate geologic map of Mars in order to better comprehend its past. Perseverance had a great year in 2021, and it'll be moving on to even more fascinating territory next year, the Old River Delta. For years, scientists have been fascinated by this fan-shaped structure, and Farley estimates that the rover will arrive at the delta in 6 to 8 months. The delta's rocks are likely sedimentary, trapping and conserving valuable layers of silt from the river that previously flowed into the crater's lake. And the samples could reveal whether organic chemicals linked to life or perhaps microfossils are hidden inside the delta's ruins. Conclusively, astrobiology, especially the search for traces of ancient microbial life, is a significant goal for Perseverance's mission on Mars. The rover will study the planet's geology and climate history, lay the route for human exploration of Mars, and be the first mission to gather and cache Martian rock and regolith, or broken rock and dust. Following NASA missions, in collaboration with the European Space Agency, spacecraft would be sent to Mars to collect these sealed samples from the surface and return them to Earth for further investigation. The Mars 2020 Perseverance mission is part of NASA's Moon to Mars exploration strategy, which includes Artemis lunar missions to help prepare for human exploration of Mars. That's it for the video, guys. Let us know what you think about the discoveries made by the Perseverance rover on Mars down in the comment section. Also, don't forget to like the video and subscribe to TechBag. Stay safe, and we will see you in the next video.